Imagine this. The Vietnam War is in full swing, and the skies over Southeast Asia are a battleground where American air superiority is suddenly under threat. The mighty F-4 Phantom, once the pinnacle of U.S. aerial power, finds itself outmaneuvered by the smaller, nimbler Soviet-made MiG-21. The realization that size and speed are not enough to dominate the skies leads to a revolutionary rethink in fighter aircraft design. Enter the F-16 Fighting Falcon, a lightweight, agile fighter crafted not just to match, but to outclass its adversaries in close-quarter dogfights. Born from a combination of hard-learned lessons and cutting-edge technology, the F-16 has stood the test of time, becoming one of the most ubiquitous and effective fighter jets in the world. The F-16's legacy is not just one of past successes, but also of ongoing relevance in modern conflicts. The ongoing conflict in Ukraine highlights the F-16's enduring value. During the Vietnam War, the U.S. Air Force's F-4 Phantom, a large, heavy, and powerful fighter bomber, was expected to dominate the air. However, it quickly became apparent that the F-4's lack of maneuverability, poor pilot visibility, and telltale black smoke trails made it vulnerable to the smaller, more agile MiG-21. These Soviet-built aircraft, with their lightweight frames and superior low-speed maneuverability, often outmaneuvered the F-4s in dogfights, leading to staggering U.S. losses. In response, the U.S. military commissioned the Red Baron study to identify the tactical and technical flaws in their aircraft and strategies. The study's findings were clear. A new type of fighter was needed, one that prioritized agility, speed, and the ability to dominate in close quarters combat. This led to the development of the F-16, a fighter designed around the principles of energy maneuverability, a concept that revolutionized aerial combat. The concept of energy maneuverability, developed by Colonel John Boyd and mathematician Thomas Christie, became the cornerstone of the F-16's design. Unlike its predecessors, the F-16 was built to manage both kinetic and potential energy efficiently, allowing it to outmaneuver opponents across a wide range of speeds and altitudes. The energy maneuverability diagrams that emerged from this research were complex, but they provided a clear blueprint for creating a fighter that could sustain high-speed turns without losing altitude or energy, crucial for dogfighting. One of the most striking comparisons is between the F-16 and the F-4. While the F-4 could make a maximum turn of just 5 degrees per second at Mach 0.4, the F-16 could achieve a turn rate of 13 degrees per second at the same speed. This difference meant that the F-16 could complete a full 360-degree turn 11 seconds faster than the F-4, a significant advantage in the heat of battle. The principle of energy maneuverability, pioneered by Colonel John Boyd, was revolutionary because it shifted the focus from raw power and speed to the effective management of a fighter's kinetic and potential energy in combat. Boyd, with his deep experience from Vietnam, understood that a fighter's ability to maintain energy while maneuvering was key to outlasting and outmaneuvering an opponent. The energy maneuverability theory provided a scientific basis for evaluating and improving fighter performance, using mathematical models to predict how different aircraft would perform in various combat scenarios. The F-16 was designed to excel in these scenarios, with a focus on sustaining energy during high-speed turns, which are critical in dogfights. This was a stark departure from earlier designs that emphasized speed and altitude over agility. The energy maneuverability diagrams used in the F-16's development were complex, integrating variables such as thrust-to-weight ratio, drag, and lift coefficients. These diagrams guided the engineers in crafting a jet that could outperform its adversaries in the dynamic environment of aerial combat, where the ability to turn quickly and sustain that turn could mean the difference between life and death. The F-16's design philosophy is evident in its engine inlet, which was optimized for the transonic speeds, 0.8 to 1.2 Mach, where most dogfights occur. Unlike previous aircraft designed to excel at speeds above Mach 2, The F-16's inlet was engineered to enhance performance in the speed range where it was most needed. The aircraft's intake placement beneath the fuselage and its thin, elongated wing with leading-edge strakes are other design elements that highlight its focus on maneuverability and energy efficiency. These strakes and the leading-edge flaps of the F-16 play crucial roles in delaying airflow separation during high angle of attack maneuvers, effectively preventing stalls and ensuring that the aircraft maintains lift. This capability allows the F-16 to execute tight turns and aggressive maneuvers that would be impossible for less advanced fighters. The F-16 was the first fighter aircraft to employ a full fly-by-wire system, a technological leap that transformed how pilots controlled their aircraft. Unlike traditional mechanical systems, which relied on a complex network of cables and hydraulics, the F-16's fly-by-wire system used electronic signals to control the plane's surfaces. This innovation not only reduced the aircraft's weight, but also allowed for unprecedented precision in maneuvering. Interestingly, the initial versions of the F-16 had a control stick that did not move, relying entirely on force sensing. However, pilots found it challenging to judge their inputs without physical movement, leading to the addition of a slight stick movement in later models. Despite this adjustment, the F-16 remained prone to pilot-induced oscillations, TIOs, particularly when carrying heavy external loads, a quirk that pilots had to learn to manage. The introduction of the fly-by-wire system in the F-16 represented a quantum leap in aircraft control technology. Before this innovation, pilots relied on mechanical linkages that directly connected their control inputs to the aircraft's control surfaces. These systems were not only heavy and complex, but also limited the pilot's ability to make rapid, precise adjustments during high-G maneuvers. The fly-by-wire system, by contrast, replaced these mechanical linkages with electronic signals, drastically reducing the aircraft's weight and allowing for more responsive controls. This system also introduced a level of safety and efficiency previously unattainable, as it could automatically adjust control surfaces to optimize performance and prevent dangerous situations like stalls. One of the most daring aspects of the F-16's design was its relaxed static stability, a deliberate choice to make the aircraft inherently unstable in flight. This instability, counterintuitive as it might seem, allowed the F-16 to respond more quickly to pilot inputs, making it extremely agile. The fly-by-wire system was essential in managing this instability, constantly making tiny adjustments to keep the plane under control. The F-16's center of lift was positioned ahead of its center of gravity, unlike traditional aircraft designs where the center of lift is behind. This configuration required the horizontal stabilizer to provide upward lift, reducing the overall energy needed to keep the plane airborne and allowing for quicker and more efficient maneuvering. However, this setup also meant that without constant adjustments, the F-16 would quickly become uncontrollable, a risk mitigated by its sophisticated flight control system. To ensure that pilots could withstand the extreme forces generated by the F-16's maneuvers, several cockpit innovations were introduced. The seat was reclined at a 30-degree angle, reducing the strain on the pilot's body during high-G maneuvers. This recline, combined with a right-hand side-mounted control stick, allowed pilots to maintain better control and remain conscious during the intense physical demands of combat. Additionally, the F-16's G-suit, which inflates to squeeze the pilot's legs and abdomen, was directly integrated with the aircraft's systems, providing real-time assistance in maintaining blood flow to the brain during high-G turns. Despite being over 4 decades old, the F-16 remains a vital component of many air forces around the world, including in the ongoing conflict in Ukraine. Its blend of agility, speed, and advanced technology makes it a formidable opponent even against modern threats. The F-16's ability to carry a variety of munitions, including cruise missiles, ensures its continued relevance in modern warfare. As the conflict in Ukraine evolves, The F-16 is expected to play a crucial role in providing air support to Ukrainian forces, helping them to counter entrenched Russian defenses. Its deployment in this conflict underscores the enduring legacy of the F-16, a fighter born from the challenges of Vietnam, perfected through decades of service, and still proving its worth on the modern battlefield. The F-16 Fighting Falcon is more than just a fighter jet. It is a testament to the power of innovative engineering and the lessons learned from history. From its origins in the skies over Vietnam to its role in the current conflict in Ukraine, the F-16 continues to embody the principles of energy maneuverability and cutting-edge technology. As long as physics remains unchanged, the F-16's design will continue to influence fighter aircraft development for generations to come.